Chapter 5, progressions, right? Let's start and finish chapter 5 today, okay? So before jumping to progressions topic, progressions chapter, let's say, let's know what is a progression. Before that, let's see some sequences, okay? For example, you have 1, 5, 10, let's say 14, and can you guess the next number? Can you guess the next number? No? No? Yes, it's 18, right? But here is you face the wrong point, because the difference is 4 here, this difference is 5, this difference is 4, right? This will just confuse you guys. Whether you predicted correctly, but if this term is not given, this 5 is incorrect one. So there is some point, yes, that wrong with it, okay? So what about 0, 5, 5, 10, 15? Can you guess next number? Yes, can you guess it? No, it's not 20. Here you have 0, 5, 5, 10, 15. Ilham? No, it's not.
16.
Oh, yeah. We will go till 100 maybe.
70.
No, not 20. Malika? 10. Okay, let's go. Let's do like that. What's your answer? 20. No. 15. No. 15. No. Nodar?
We can find it.
Yes, it's 25. Nodar is correct. Yes. Surprise. Yes. 25. You're just adding previous two terms. Yes. Don't look at the difference. It always will not depend on the same pattern. Okay. What about 1, 8, 64. Can you guess the next number?
6.
So you can just tell with the powers. Okay?
256.
256. How did you find it?
We multiply by 4.
By 4? But you see, it is multiplied by 8. It's multiplied by 8. You have to multiply by 8 too.
500.
So actually, it has to be 8 on the power of 3. Or it means 2 on the power of 9. Or it means
512.
512, right? Because you know that 10's power is 1024. So, these sequences, these numbers, is creating some sequence, right? Sequence. And they are following certain patterns. Yes? And what is the formula, let's say, for the second one? AN. Formula. We have to create general formula with indexes that will be correct for the sequence of these terms, okay? We have to create some pattern, okay? AN equals to AN minus 1, previous one, plus previous one, right? AN minus 2. Is it correct? So if you are taking third term, you need second term and you need first term. If you are using this recurrent formula for the second one, okay? This is called the recurrent formula. Recurrent formula is used, okay, let's say formula. Recurrent formula is used to find the next term, okay? Next term. Recurrent formula represents pattern of the sequence, okay? You have terms within the sequence. They are called terms, okay? Here you have how many terms?
5.
You have infinite terms. Yes? Just not written. Yes? It is just not written. Yes, you can count 1, 2, 3, 4. 5 of them defined here. But if you continue, you can project many more, right? If there are any sequence that is limited, No, Malika thinks no, okay. Yes? If there are any sequence that is limited, maybe yes. Yes, it depends. From the functions, you remember, it depends on domain and range, right? If your range is limited, yes, your sequence will be limited. Okay? So, have you understood sequences and recurrent formula and how they can be? Yes, you already did, right? So, 5th power, first one, arithmetic progressions. It's just quick shot, okay? Arithmetic progressions. So Dura, can you tell me what is arithmetic progression? Yes, Dura? So you can tell series of numbers that creates arithmetic progressions. Just tell me numbers that create arithmetic progression. Okay. 2, 4, 6, 8, 10, next 12, yes? So arithmetic progression series are as follows. So what does it mean? Starting from the second term, so definition for arithmetic progression, okay? Starting from the second term, constant d number, here it's 2, d is being added to create the next term, okay? To create the next term. This constant is being added, plus d, plus d. Your constant might be negative 2. But here we are just taking 2. Okay? To create next term, plus 2, plus 2, plus 2. Okay? Here your difference. This constant is denoted with d, and it's called difference of arithmetic progression. Okay? Difference of arithmetic progression. They are called the terms of arithmetic progression. What is the first term? It's 2. What is second term? 4. What is fifth term? 4, 5, 10. What is 15th term?
A1 plus.
So you have to know the formula of an. An is a1 plus n minus 1 multiplied by this. So an is the formula used to find nth term of arithmetic progression. Okay? Nth term of arithmetic progression. So for example, you are looking for 15th term, yes, over here is only, right? If you continue, you add 2, you will find your 15th term. But we have formula, let's use them. Index is 15, it means your n equals to 15. For that one, to use this formula, you need 3 things. First, your first term. Second, what index you are looking for, and the difference, right? Your difference is obvious. It is equal to 2 in this example, right? And your first term is 2. So A15 is A1, it means 2. Plus, and your n index here is 15. 15 minus 1 multiplied by the difference. Your difference is the same as your first term, right? 2. Here you have 14. 14 multiplied by 2, so in total 30, right? 30. Actually, you can say that an equals to twice of n. This is a recurrent formula for this series, right? If you are looking for 10th place, 10th index, so you just multiply 10th term, right? You multiply 10 by 2, it will be 20. Okay? This is a recurrent formula for this arithmetic progression. Okay? Only for this one. If your first term is 4, it will change. How will it change, Ilham? If you are missing this? So this was your recurrent formula, right? 2n. But now your first term is 4. If you are putting first term and saying it will be equal to 2. How can you rearrange it so you will get recurrent formula for this series?
Multiplied by 2n multiplied by 2.
Multiplied by 2? 2n is already multiplied by 2. Maybe adding? Yes. In equals to 2 twice of n, right? Plus 2. Not 4, 2, right? If you are looking for 1, let's say you are starting from the first one, 4 is, right? 1, 2, 3, fourth term. 4 multiplied by 2, 8. 8 plus 2 is 10. So your fourth term, 8, 10. 1, 2, 3, fourth term is 10. Okay? If your progression is missing these 2, recurrent formula will change to 2n plus 2. Okay? Good. What are the properties? We have 3 properties for arithmetic progression. What are the properties? Let's say A1, A2, A3, A4, A5, A6, etc. They are creating arithmetic progression series, okay? Series of arithmetic progression sequence, let's say. So the first property says, starting from the second term, arithmetic mean of neighboring terms is equal to that term, okay? Neighboring ones. So it's called neighboring. Neighboring property, okay? Starting from the second term, arithmetic mean of neighboring terms will be equal to that term. A2 equals to A1 plus A3 over 2. And it will be equal to so for A3, it will be equal to A2 plus A4 over 2. Okay? Or in general, AN equals to AN plus 1 plus AN minus 1 over 2. Okay? This is the first property. What was the second property, Ilhan?
Equal distance.
Yes. Equal distances. What does it say? Again, starting from the second term, let's take fourth term in that case, okay? Starting from the second, it says, but you can take thirds, fourths, fifths, okay? Terms locating in equal distance. So for A4, you have, let's say your car is a distance. Car is a distance. If your car equals to 1, you take the terms of 3 and fifths, right? If your car equals to 2, you take the terms of second and 6, right? So A2, A6. If you neighboring one, A3, A5. It is a continuation of the first property, right? It includes first property within. Will be equal to that term, it says. If your car equals to 3, you take this term, right? So you add 3 to its index and subtract 3 to find that terms. 4 negativated by 3, so 4 minus 3 is 1. 4 plus 3 is 7, right? You get Z terms. A1, right? If your car is 3, plus A7 over 2. So, again, equal distances says, starting from the second term, any term, you can take any term, but starting from second term, don't take first one. Starting from any term, let's take fourth term. Arithmetic mean of terms locating in equal distances will be the same, and it will be equal to that term, okay? If you are taking fourth, it will be equal to fourth term. If you are taking third term, it will be equal to third term. Or in general, AN will be equal to AN plus K plus AN minus K over 2. Have you understood it? Iskandar? Okay, Malika? Good. What was the third property? Indexes, right? Indexes, what does it say?
Terms.
Indexes. Let's say AN plus AM equals to AK plus AL. If some of your indexes are equal, some of these terms will be equal to, okay? They will be equal. Let's say A5 plus A6 equals to A1 plus
A10.
yes, A10, right? A10. Or you can say it will be equal to A2 plus A4? No, 9. Because you have some of these indexes being equal to 11, right? So this is general formula, this is specific case, okay? What is the sum formula? Sum formula says your n starts from 1 till, let's say, n. So you're using an, meaning that you have to put starting from 1 till n to guess the terms A1, A2, A3, plus etc. an. So you're finding first n terms sum, okay? Sum of the first n terms. It will be equal. Can you tell me the formula? Yes?
A1 plus AN divided by
Multiply by n. Or you can replace your an with the formula provided over here. A1 plus A1 twice of your A1 plus n minus 1 multiplied by D divided by 2 multiplied by n. Or you can divide it and multiply and etc. Okay, you can simplify it as you wish. Okay, this is sum formula. We will look through exercise and understand it more deeply. Okay, have you understood it? Do you have any questions? Muntos? No questions, Oyhan? Okay, copy that. We will erase it soon. Done copying, Malika? Let's start from simple ones. First one. A part 0, 4, 8, 12. Can you guess next number? 16. So what is first term? What is your difference?
Difference is 4.
Your first term is 0. Yes, this number. It's now visible 0. Yes. Let's do C part. 53, 42, 31, 20, etc. Can you guess next number? Yes, it's 9. Yes, it's 9. And what is the next number? Minus 2. So starting from which term, the terms will be negative? 1, 2, 3, 4, 5, starting from 6th term, right? It will be negative. What is your first term?
53.
53. What is your difference? Minus 11, right? So constant Z, constant D is being added to create the next term. You remember? Yes, actually your difference is equal to AN minus 1. Yes. Let's turn to second one. In arithmetic progression, 12, 15, and etc. Find fifth term, A5. So if you continue, you can guess the number by let's use formula, okay? A1 plus n minus 1, 5 minus 1, multiplied by the difference. Your difference is 3. 4 multiplied by 3 is 12. Plus 12, you get 24. Yes? Third one. So this was A part, you will do B part at home. Third one, write down 6th term, A6, of 19, 15, etc. So let's use formula again. A1, your A1 is 19, plus n minus 1. 6 minus 1 is 4, right? 6 minus 1 is 4?
5.
It's 5, yes? So multiplied by, what's your difference?
Minus 4.
Yes, it's minus 4, right? Minus 4. If you multiply, you get minus 20 from here. If you add 19, you will get minus 1, right? Let's look at fourth one. For the arithmetic progression, A1 equals to 8, and your difference equals to 4. Calculate A10. The same, right? So 9 times of your D plus first term equals to 10th term. 8 plus 36 equals to 44. So this is fourth. Let's look at fifth. A10 equals to 192. So quite different. Difference equals to 2. Belongs to an arithmetic group. What is the value of A1? You have to find first term, okay? You can open this A10 as being A1 plus 10 minus 1, n minus 1, right? 10 minus 1, 9 times of D. Your D equals to 2, equals to 192. Can you tell me first term? 9 multiplied by 2 is 18. 192 minus 18 is? 60. Oh, great. 74? 2. It's 192. You're subtracting almost 20. 174. Yes? Not 64. This is the first term. Subtraction işlerden çıkarttı. Ne olur? 6-1. Your 10th term is 13. Your 5th term is 18. So it's 13, it's 18. And given for arithmetic, find its common difference. You have to find Z. 10th term, 5th term. You can expand 10th term in terms of 5th term, or you can say A10 minus A5 equals to 5 times of D. And it will be equal to 13 minus 18 minus 5. What is your D, Notor?
Minus 1.
Yes, obviously. What is your first term?
A10 minus A1.
So you can expand A5 as being A1 plus n minus 1. It means 4 times of D. Your D is minus 1 and it's equal to 18, right? Minus 1 minus 4 plus 4. Your first term is 22, right? 2 was 6. Let's look at 7. Find an arithmetic progression. So if an arithmetic progression has first term being equal to 1, difference being equal to 4, is the number 10,091 a term of this progression. So you have first term, you have difference, you have to find if it's an or not, okay? I put question sign, okay? You have to find it, whether it's this term. Let's equalize, let's say it's an, and find whether n is integer or not. Natural number actually. right? If it's natural or not. If it's not, we can reject that this term is not in this progression. If it is, then you can conclude properly, okay? So first term plus n minus 1 multiplied by your difference, right? You open the bracket. So 1 plus 4 times of n minus 4 equals to 10,091. If you negative this with 1, it becomes 10,090, and if you add 4, 94 equals to 4 times of n, right? It is not divisible by 4. Yes. What is the divisibility rule for 4? Great.
Last two digits must be divisible
Yes.
by 4.
Last two digits,
Must be divisible.
yeah, it should be divisible by 4. It is not, right? It means your n is not natural number, so you can reject this term being a term of this arithmetic progression, okay? First term is difference 8. Given your first term being equal to 8 and your difference being equal to 4, find as 16. Now we are using different formula. Now we are jumping to the sum. Can you tell me as 16 formula? Yes, you can. Another? an. Now it's 16, right? a16 over 2 multiplied by which number? 16, yes. There is a cancellation, 8, right? a1 equals to 8, a16 equals to a1 plus 15 times of your difference. It's 60, so 68, right? 68 plus 8, what is the sum? 76. Multiply by 8, you will continue, okay? 9. What is the arithmetic mean of the first 1,000 natural numbers? So it says first 1,000 natural numbers, that's why you have to start from the first one, because natural rows, right? Number of natural rows start from 1, 2, 3 till 1,000. You have to find the arithmetic mean. What was the formula of arithmetic mean, Malika? Okay. So sum of all the terms, yes, all of the numbers starting from first one till n divided by
1,000.
number, right? N. So if you have 1,000 terms, you have to divide by 1,000. But this formula is a sum formula, right? You have to add them. They are creating arithmetic progression sequence, right? So you can use as n formula, as 1,000 formula, and divided by n, so by 1,000, right? Equals to 1 plus a1 plus an divided by 2 multiplied by 1,000. And you have to divide it by 1,000, 2, right? And there happens cancellation. 1,001 divided by 2 is 505. That is 1,001, right? 5 and half. 500 and half, right? So there was 9. Let's turn to 10. The first row of a cinema contains 21 seats. That's an interesting question. The first row of cinema contains 21 seats. So it means here you have 21 seats. In every other row there are 2 more seats. So here you have 23. Here you have 25, etc. How many seats are there in the 40th row? So you're asking this first one, this second, this third, and 40, right? So how to find it?
Yes.
Your A1 is this. What is your difference?
Is 2.
You are adding 2, right? So 39 times of n, d, right? It's 2, plus your first term, 21. What is the sum? 878, right? 99? 99 seats in 40th row. It's very crowded, yes. 11. 7. A2, A3, A4, A5, and 22 are the first 6 terms of arithmetic progression. Find the sum of these numbers. A2, A3, A4, A5, okay? How to find the sum? So which term is that? First, second, third, fourth, fifth, and sixth, right? So this is 6th term. Can we find difference from here? It's equal to a1 plus 5 times of difference, and your A1 is 7, right? 7 plus 5 times of difference equals to 22. Your difference is 22 minus 7 is 15, divided by 5 is 3, right? Your difference is 3. If you add 3 here, it will become 10. And next is 30, next is 60, next is 19. You add these 4 numbers, okay? Add. Or you can use properties. A3 plus A4 equals to A2 plus A5 equals to 7 plus 2. Yes? Indexes. So it means you have how many times of them? Sum of these two numbers. 1, 2, 3. 3 times of the sum of these numbers. Okay? You have 29 multiplied by 3, you calculate it, okay? 87. 12. If in an arithmetic progression, A6 equals to 10, as 16 equals to 200, can you find A11?
Yes.
So this is 10. Yes, we can, but we don't know how. Yes? Okay. So S16 is A1 plus A16 divided by 2 multiplied by 16. And there is cancellation, 8 and another cancellation. Which number do you have over here? If you divide 200 by 8.
25.
Yes, 25. It means A1 plus A16 equals to 25. Yes? You have 6th term and 11th term. Look at the indexes. If you sum them, they will be equal, right? 16 plus 11, plus 1 is 17, and over here you have also 17, yes? It means the sum of them are the same. They are 25. If 6th term is 10, what is 11th term? 25 minus 10? 15, right? It's 15. Let A be C. Okay, let's see it. It is more geometry, but let's see it. A, B, C. Be a triangle whose angles measured in degrees are in arithmetic progression. Let A be the list of angles. Let's say A1, because it's formulating arithmetic progression, right? The least one, and C the largest one. Let's say it's C, and it's B. C the largest one, it's A3. And B is A2, because you have 3 consecutive terms, right? Of arithmetic progression. A1, A2, A3. A3 is the largest, A1 is the smallest. We are supposing that your D is positive, okay? And making that pre-assumption, okay? Let A be the least, C the largest. If the internal bisectors of A, so you are releasing bisector from A, and C, releasing bisector of C, so they are meeting somewhere, and this point is denoted as I. Calculate the angle of AIC, so you have to find that angle. We know that internal angles of any triangle equals to 180, and from neighboring property you can find A2 value. It's equal to 3 times of A2, right? Because A3 plus A1 divided by 2 equals to A2. If you multiply 2 on the other side, it will twice of A2. Is that A2? It will be 3 A2, right? Equals 180. And A2 is 60 degrees. So this is 60 degrees. And A3 is 60 degrees minus difference. A1 is 60 degrees, so plus difference, right? Here minus difference.
80.
Yes? It means this is half of them, half of it, right? Because we are releasing bisector. Half of it equals to 30. Minus D over 2. What about this part then? So we are releasing bisector. A, so 60 divided by 2, 30. This was A3, right? We are dividing it by 2. Plus difference over 2. So this angle is this one. This angle is 30 plus D over 2. Can you find this angle? So let's denote it as X, okay? Plus one angle and another angle, 30 minus D over 2. The sum of internal angles of any triangle equals 280 degrees, right? And there happens cancellation, and you conclude as your X being equal to 120 degrees. Yes, the sum is 60, 180 minus 60 is 120. Yes, Rohan? Do you have any questions? No question, right? Okay. Let's turn to 14. In an arithmetic progression, your first term is 5 and your difference is 10. The sum of the first n terms equals to 32,000. Find n. So you have to find n. Sn formula. Can you tell me the Sn formula? Yes, please do. Let's use twice of A1, okay? The next formula. Yes? Tell me. Okay. It's equal to 32,000. Yes? Your A1 is 5. 5 multiplied by 2 is 10. Plus n minus 1 multiply your difference is 10. Over 2 multiplied by n equals to 32,000. Let's divide both sides by 10. And you get 1 plus n minus 1. It means n. Yes? And multiplied by n, it will be squared. And if you multiply another side by 2, it becomes 6,400. And your n equals to? Actually, it's equal to plus minus 80. But you are looking for the number of terms, so it will be natural number. Because natural numbers are used for counting, right? Let's turn to 15. A1, A2, etc. A16, A17 equals to 136. What is A6 plus A12?
A17, A1 plus A17.
So yes, it is equal, but you have to calculate it, right? A1 plus A17, A2, A16, they give the same indexes, right? Some of the indexes are the same. 17 plus 1 equals to 6 plus 12, right? 12's term, and the index is 2. 2 plus 16 is 18. 6 plus 12 is 18 too. What is the number in the middle? What are the number pairs actually? So if you are shortening them, starting from 1 till 17, between you have in the middle you have one term. A8 or 9? A9, right? A9. So what are the neighboring ones? A8 and A10, right? So how many pairs of A6 and A12 do you have? Or here, 17 and 1 equals to this one, it means one pair. Next one, second and 16th, you have another pair. How many pairs do you have? 8 pairs, right? It means we have 8 pairs of it, and A9 plus A9. It is equal to 136. You can replace A9 with A6 plus A12 over 2, right? So it means how many A6 plus A12 do you have? 8 plus half. 8 plus half. 8.5, right? So you divide 136 by 8.5. And this is your result, okay? Is that 16? Okay, I see you are using calculator. No? Okay. It's good if you have not. 16. The sixth term of arithmetic progression is 4 times, 16 term is 4 times less than 9th term. Means if you are multiplying 16 term, it will be equal to 9th term. Yes? And their sum, A9 plus A16 equals to, their sum equals to, which number? 20. So you solve simultaneous equation, okay? This is 16, this is 16, this is 9, okay? You can expand it. A16, A1 plus 15 times of D, and A9 is A1 plus 8 times of D, and the same for the next equation. You just have equations of A1 and D. You will solve it. You will find D and A1 that makes them simultaneous, okay? That satisfies them simultaneously. Do you have any questions, students? No questions? Okay, copy. Okay, let's look at 20, okay? 1 over 2 plus 1 over 3 plus 2 over 3 plus 1 over 4 plus 2 over 4 plus 3 over 4 plus etc. Please plus in bracket 100 1 over 10 2 over 100 plus etc. 9 over 100 over 100. So how to calculate it? It was a great jump, right? Okay. This value is 0.5. This value is 1. What about this value? 1.5. Etc. Arithmetic progression is being created, right? What about the last term? 49.5? Yes. Okay, the first term is 1 over 100. The last term is 99 over 100. But what term is that? Look at the numerator. It starts from 1 till 99. It means the last one is 99 term, right? So let's find as 99 for this bracket only, okay? So first term plus 99 term, 99 over 100, divided by 2 multiplied by 99. Here we have 1, right? 99 plus 1 is 100, 100 over 100, it's 1 over 2, 0.5 if you multiply it, and no, that was correct, right? Okay, 49.5. What is your difference here? 0.5, right? How can you find sum? First term is 0.5 and the last term is 49.5 divided by 2. How many numbers do you have? 99? 90. Okay. 99. 49. No, how many brackets do you have, let's say? No, you have many more over here, you see? It starts from 2. Look at the numerator. 2, 3, 4 till 100. How many numbers do you have? No, you are missing 1. 99 terms, right? And it's 50 divided by 25 multiplied by 99, and it will be 40,000, right? No. 2,475? Okay. Let's turn to 21. Interesting. 1, 2, 4, 2, 4, 8, 3 multiplied by 6 multiplied by 12 plus etc. plus 20, 40, 80. Over 1 multiplied by 3 multiplied by 9 plus 2 multiplied by 6 multiplied by 18 plus 3 multiplied by 9 and 27, etc. 20, 60, 180. So, do you have any ideas, Skandar? So, do you have any ideas? Multiply, then multiply, multiply, multiply. Yes?
Let's calculate first
Let's take, we have 3 terms, right? Actually, this is the first term, but we have 3 numbers in the first term. And the same for the second term, right? Etc. till, how many terms do you have? Look at the first one, 1, 2, 3, till 20, yes? And you can see at the second numbers, they are being multiplied by, which number? First term is being multiplied by 2 to create the next term, yes? 3 multiplied by 2 is 6, 20 multiplied by 2 is 40. So, again, first term is being multiplied by 4 to create the last term, right? Last number in the term. It means you can take 2 from the first number, from the second number, and 4 from the third number. So it means 8, right? To multiply by 4. If you are taking 8 out of the bracket, you are leaving 1, 1, 1, 1 cube, right? If you are taking 8, you are taking 2 and 4. 2 from the second, 4 from the third one. You are left with 2 cube, right? Plus, etc. Plus, so here you have, Diora, can you tell me? Yes? Yes, tell me. So you are taking 2 from here, from the second number, you are taking 4 from the third number. What you are left with?
8.
You are taking some numbers out of the bracket, right? So what is left? 20 on the power of 3, right? So if you are doing the same, you are taking 27 out of the bracket. From the first one you are doing 1 cube, and then 2 cube, plus etc. plus from the end, what you are left with? Yes? Are you listening to us? So you are taking 3, you are taking 9. 3, yes. 20 on the power of 3, and there happens cancellation. What is your answer, Oyhan? 27, yes. 8 over 27, and that's it, okay? Please be attentive. Okay, Diora. Let's look at some problems from homework, because we are like having less time. 5, have less time. S5 minus 3 times of S4 plus 3 times of S3 minus S2. If Sn is the sum of the first n terms of arithmetic progression, find this one. So you are seeing 3, 3, yes, and you are facing some of the numbers that don't have any coefficients. S5 minus S2. What is the result? This is not S3. Okay, this is not S3. Why? Because S5 is sum of first 5 terms. S2 is sum of first and second term, right? It means if you are subtracting from the first 5, sum of the first 5 terms, the first 2, right? S2. You are left with other 3 terms, right? 1, 2, 3, 4, 5. You are subtracting 1, 2. You are left with 3, 4, 5, right? So A3, A4, A5. If you understood it, we are just calculating this number. You are taking minus 3 out of the bracket. From the first one you are left with S4, from the second one S3 with negative sign, right? You are taking minus, so if you open the bracket it will be plus again. S4 minus S3, what is the difference?
A1.
No.
A4.
Yes, A4. How is that? Because S4 is A1, A2, A3, A4. And S3 is A1, A2, A3. And you are left with A4 only, right? Minus 3 times of A4. And what about this one? You can use neighboring terms, the property of neighboring terms, right? Here you have 3 times of S4 to A4, right? And your result is nothing, right? Let's look at 6. How many terms of arithmetic progression? 4, 10, 16, etc. must be added to get 198. So you have to find such as n that will be equal to 198. So how to find it? You have to know Sn formula, but before that, let's write first term, let's write difference. What is your first term? 4. What is your difference? 6. So Sn formula, we have to find n, okay? We have to find n. 198. Yes, this is Sn. The formula for that, twice of your A1 plus n minus 1. We don't know n. N minus 1 multiplied by d. D equals to 6 over 2 multiplied by your number of terms. We still don't know it. You have to find n from this equation, okay? If you divide it by 2, so that happens 3. Cancellations, 198 equals to 4 plus, if you open the bracket, you have minus 3. 4 minus 3 is 1. Plus 3 times of n multiplied by n. You open and solve it by discriminant. Please note that n should be natural number, okay? Have you understood arithmetic progressions? Can we turn to the geometric one? Yes? 5.2. Geometry progressions. Munisa, can you tell me the series of numbers that create geometry progression? Okay. Yes. 2, 4, 8, 16, 32, and etc. Right? So, Geometric progression, the definition of geometric progression, starting from the second term, constant q is being multiplied. For the arithmetic progression, it was constant d number is being added, right? Now here you have constant q number. Here your q equals to 2. It's being multiplied. It's being multiplied by 2, okay? Multiplied by 2. What is the next term? 64, right? And this series are creating geometric progression, okay? So again, geometric progression, starting from the second term, the definition for geometric progression, okay? Starting from the second term, constant q is being multiplied to create the next term, okay? First, second, third, fourth, fifth, sixth. What is seventh term? 128, or you can use the formula, Bn formula. So b1 multiplied by q on the power of n minus 1 is the formula to find nth term of geometric progression, okay? So for arithmetic progression, it was the same. It was similar, right? It was similar. Here you had a1, here you have b1. It was plus n minus 1 multiplied by d. You have q on the power of n minus b. Because you are creating the series by multiplying, so you work with powers here, okay? And there is plus, minus, okay? So what is 8th term? Theoretically, it should be 256, right? Now let's use the formula and see whether it's correct or not. b1, 2, multiplied q is 2, on the power of n minus 1. Your n is 8, 8 minus 1 is 7. So 2 on the power of 7 is? So in total 2 on the power of 8, it is? 256, the same, right? So nth term of a geometric progression is defined using this formula, okay? What about the properties? First property, again, neighboring terms, right? b1, b2, b3. So let's write n, neighboring means, okay? Starting from the second term, let's say third term. Let's take third term, guys. Third term, geometric mean, right? Geometric mean of neighboring terms will be equal to that term, or square of that term will be b3 square. Yes, you are squaring both sides. Square of that number will be equal to the multiplication of, or product, let's say product of neighboring terms, b2 multiplied by b4, okay? Or general formula, bn equals to under the root of bn minus 1, bn plus 1, okay? Have you understood it? Okay, what was the second property for arithmetic progression? Do you remember it?
Equal distance.
Yes, equal distance. The same, equal distances. Let's have b5, b6 formulas, terms here. So it includes neighboring, but it is expanded by the distance. Let's say your distance is k, bn plus k, bn minus k are the terms that are away or behind that term. The geometric mean of these terms will be equal to that term, okay? Or square of the term will be equal to the product of these terms. Let's look through the example. b3 equals to, if your car, let's say distance equals to 2, Munisa, if your distance equals to 2, b3 minus 2, so it's b1, and you have 2 space ahead, b5, right? Arithmetic, geometric mean. b1, b5. You can see the proof. b5 is b1 multiplied by q on the power of 4. b1, b1. Here you have b1 squared under the root equals to b3. If you are taking square root, it will be b1 q squared, right? b1 q squared is your b3. Yes? All fun? If you understood it. What was the third property? Indexes. Yes? Indexes. Let's say b1, bn equals to bl plus bk, right? n plus, here you have multiplication of the n plus m equals to l plus k. If the sum of the indexes are the same for geometric progression, okay? If the indexes are the same, the product of z terms will be equal. Let's say b5 multiplied by b2 equals to b1 multiplied by b. Can you tell me the index? It's not 3. So you have 5 plus 2, it's 6. It's 7, right? 5 plus 2 is 7. Here you have 1, here you will have 6, okay? It means b1 multiplied by q on the power of 4, b1 multiplied by q, b1 and b1 multiplied by q on the power of 5. You look at the powers of q, it is 5, and b1s, here you have 2, here you have 2, multiply, right? This just proves that they are equal in reality too. So this is a formula, not formula, this is property, okay? For indexes, here you have equal distance, here you have neighboring terms. So what about sum? In arithmetic progression we used sum, right? Here you have also sum. Yes, you have products, you are working with powers, but here you have sum. Sn equals to b1 multiplied by q on the power of n minus 1, q minus 1, or you can take minus from numerator and denominator from both of them out of the bracket and create another formula. Actually they are the same, okay? 1 minus q. Whether you can use this formula or this formula, it matters less. Okay? So let's talk about q then. If the model of your q is greater, absolute value, right? Absolute value of your q is greater than 1. So what will happen? Yes, your terms will be ascending, right? When your q is less than 1, what will happen? Model of q. So your terms will be decreasing, right? Decreasing. Infinitely decrease, right? What if your q is negative? Also decrease? No. It will have? No. No. Alternating signs. Alternating signs. So for example, your first term is 2 and your q, let's say some negative number, minus 2. It will be minus 4. The next term is 8. The next term is minus 16. So you have alternating signs. Okay? Alternating signs. Plus, minus, plus, minus, plus, minus. If your first term is negative, your second term will be plus. So again, alternating, okay? It depends on your q, not your first term. If your first term is negative and your q is positive, you will have negative terms, all of them, okay? If your first term is negative and your q is positive, you will have negative terms. If your q is positive and your b1 is also positive, you will have all of the terms positive. If it's positive and greater than 1, it will be in ascending, okay? If it's positive but it is less than 1, it will be decreasing, okay? But not alternating. Okay? Have you understood it? So in this case we have special sum formula. So let's create some. 1 over 5, 1 over 25, 5, etc. What is your b1? 5. What is your q? So you divide b2 to b1 or b3 b2. Okay, you can divide. To find, let's write over here. To find the q, bn divided bn minus 1. Okay, you can divide that term to the previous one. Okay, for example, you are taking 1 over 5, dividing by 1, it's 1 over 5. Or you are dividing 1 by 5, it's 1 over 5. Yes, your q is this one. And your q is creating you some descending, infinitely descending geometric progression series, right? Where the first term is 5. Can you find the sum of these infinite numbers? Yes, you can. Irrespective of the numbers of the terms you have being in infinite, right? In number. Infinite terms you have here. But you can find the sum. So let's use S formula for that one. New formula, b1 over 1 minus q. Okay, b1, 1 minus q. Can you calculate it for this one? Let's write it over here. That's equals to, your b1 is 5 divided by 1 minus, your q is 1 over 5, yes? Here you have 4 over 5, 5. What is the result? No. So this is division. If you multiply it, it will inverse. So 25 over 4, right? It means 6.25. But you see, the first two terms, if you sum them, it will be equal to 6. The rest, some of the rest terms will be equal to 0.25. Yes, it's interesting. But anyway, okay? Have you understood it? Theora? Okay, copy. Let's start from the simplest one first. Identify geometric progression. 2, 4, 8, 16. What is the next term? 32 and 64. So it says identify geometric progression. Your B1 equals to 2. Your Q equals to 2, 2, right? You divide any term to the previous one. So second one. You will do B, C, D part on your own, okay? But let's look at D part 2. 2 minus 2, 2 minus 2. The next term is 2 and minus 2. So what is your Q, guys? Yeah, it's minus 1. You see it's alternating. The signs, alternating. Your B1 equals to 2. Okay? Second one, in geometric progression 5, 10, 20, etc. Find B10 and find S10. So what is your first term? It is 5, yes. What is your Q? 2. Your B10 is B1 multiplied by Q on the power of 9. Yes, you are using the formula of Bn. B1 is 5 multiplied by Q, 2 on the power of 9. What is the result? 512 multiplied by 5?
2,560.
205,000. So 2,000, right?
Yes.
560.
60.
So what about S10? S10 is B1 multiplied Q on the power of 10 minus 1 divided by Q minus 1, right? Q minus 1. And here your B1 is 5, your Q is 2, 2 on the power of 10 minus 1 over 2 minus 1. So 2 minus is 1, so you just neglect it, okay? 5 multiplied 1024 minus 1, 1023, right? If you multiply by 5, you have 5, 1, 10, 1, 1, 1, or 5, yes? Here you have 5. 5150, yes? Third one. In geometric progression, your second term is 6, your fifth term is 162. Compute B1 and Q. So let's compute Q first. If you are dividing B5 by B2, B5 divided by B2, what is the power of the Q? It means you have to take cubic root to find your Q, right? So B5 divided by B2, what is the result? 23, 27, right? Cubic root. If you are taking cubic root, it will be 3. Your Q equals to 3. Have you understood it? Okay, what about B1? If you divide B2 to B1, you get Q, right? It means you have to divide B2 to Q to get B1. It means 2. Okay? 4. What is the sum? 2 plus 4 plus 8 plus etc. plus 256 plus 512. So first you have to check whether terms are creating geometric progression. If yes, then you can use ascent formula. So what was the ascent formula? B1 multiplied Q, so your Q is 2, on the power of how many terms do you have? This is 2 on the power of 1, this is 2 on the power of 2, right? This is 2 on the power of 9. It means starting from first one till 9th one, the power of 2's are written, right? In total you have 9 terms. 2 on the power of 9 minus 1 divided by 2 minus 1, Q minus 1, right? Equals to?
1,012.
So this one is 512 minus 1, 511 multiplied by 2, right?
1,022.
1,022? Not 100 but 1,000, right? Not 100 but 1,000. Fifth one. The first term of geometric progression is 150. And the fourth term is 1.2. Find the fifth term. What is your Q equal to? It is equal to cubic root of B4 divided by B1. Right? If you divide them, you get Q cube. Right? If you are taking cubic root, so this will be your answer, okay? You will have Q as a number at the result.
0.
So can you divide it, guys?
Yes.
Yes, divide. 0.8? You mean this one?
0.08.
Cubic root, you mean? Okay, let's calculate it. Okay, let's calculate it. 1.2 is 12 divided by 1500, and you face cancellation. If you cancel them by, is it divisible by 12? Yes, it is. If you divide it, here you get 1, here you get 1, 30, 2, 24, 65. Yes, and you are taking cubic root. So it becomes 1 over 5 is 0.2. Let's do 6. In geometry progression, your q equals to -2 and s5, I guess, yes? Or whether 6, okay, 5.5. Find your b5. So s5, 5.05, equals to b1 multiplied by q on the power of 5 minus 1 divided by q minus 1. And here 5.5 equals to, let's find b5, okay? 5.5 equals to b1 multiplied by, what is your q? -2. -2 on the power of 5 is -32, -1, -33. Divided by -2, -1, -3, and you face cancellation, 11. If you divide 5.5 by 11, you get? You get which number? So it is 55 divided by 10, and there is cancellation, 5. 1 over 2, right? Your first term is 1 over 2. What about your fifth term then? 1 over 2 multiplied q on the power of 4 minus 2 on the power of 4, power of 4 is 16. And you face cancellation, it is 8. Okay? Let's turn to 15. Under the root x, under the root x, under the root x, etc. Equals to 2009. So for the first x, you have only one root, meaning that x on the power of 1 over 2 if you change root to power, okay? For the second one, you have two roots, right? X on the power of 1 over 2, 1 over 2. The power of the power should be multiplied. 1 over 2 multiply 1 over 2. You get 1 over 4, okay? For the third one, you have three of them. X, 1 over 8, etc. 2009. And they have the same basis. You just add their powers. 1 over 2, 1 over 4, etc. Right? Equals to 2009. What is the sum? You are creating decreasing geometry progression, infinitely decreasing geometry progression, right? The first term is 1 over 2. So you are using b1, 1 minus q. 1 minus your q is the same as your b1. 1 over 2, 1 over 2, it's 1, right? X on the power of 1 is x itself, and it's equal to 2009. You have to find your x, okay? 18, let's look at 18. 2 plus 35 over 100. 35 over 10,000. 35 over 1 million, plus etc. Calculate the sum. So what is the sum of them? 2 plus, let's take 35 out of the bracket. You are left with 1 over 100, and 1 over 10 on the power of 4, 1 over 10 on the power of 6, etc. And here you are creating also infinitely descending geometry progression, right? It is decreasing. Your first term is 1 over 100, and what's your q? To find the sum, we are using S formula, okay? P1, 1 minus q. Your q is the same, right? You have 1 over 100, here you have 99 over 100. So your result is 1 over 99, isn't it? You multiply it, so you don't face any cancellation. So your result is 2. Here you have 2, right? And 35 over 99. Or you can change it as 2, 35 periodical. Yes? Let's do 19. Your q equals to half. S6 equals to 63 over 2. Let's find b5. What is the formula for S6? b1 multiplied by q, 1 over 2, on the power of 6, right? Minus 1 divided by q minus 1. So 1 over 2 is, can you tell me the result?
1 over...
So it's equal to b1. 1 over 64 minus 1, here you have, divided by half, right? With negative sign. And here you have, you give common denominator, 64. And you get b1, 36 or 63. Minus 63 divided by 64 minus 0.5. So it means minus 1 over 2. If you change it, it will be minus 2 if you inverse the number, right? So this number is equal to this one, and these negatives are not needed. 63 divided by this one, 2 divided by 64 is 32. 32 multiplied to this side, actually there is a cancellation, right? 16. So your B1 equals to 16, right? B1 is 16. Your B5 equals to B1 multiplied by Q on the power of 4. It means 60 multiplied by, your Q is half on the power of 4. Yes, it is 1. Let's look some problems from homework. Let's look at third one, okay? It is known that A equals to A term, B8. B equals to BB. Your C equals to BC. Shows that A on the power of B minus C, B on the power of C minus A, C on the power of A minus B equals to 1. Yes, Malika? Do you have any ideas? No ideas? Mumtaz?
Is it progression? Descending progression?
No. Let's say B1 multiplied by Q on the power of A minus 1. And B1 multiplied by Q, B minus 1. And B1 multiplied by C, Q on the power of C minus 1. And let's replace your A, B, C's over here, okay? So this A is this one, your B is this one, your C is this one. B1, Q on the power of A minus 1 on the power of B minus C. Power of the power. And here you have B, B1, Q on the power of B minus 1. And on the power of you have C minus A, right? You have C minus A. Multiplied by C, you have B1, Q on the power of C minus 1. And on the power of A minus 1 equals to 1. Yes? And power of the power should be multiplied. Yes? Okay. B1, here you have B1, B1, B1. And the powers of the first one, meaning that 1 multiplied by this number is the same numbers. If you're adding their powers, you get B minus C, C minus A minus B. And it is the same for Q. Okay? You multiply their powers and write it over here, equalize it to 1. You will do it at home, okay? Because we have more calculation, we don't have space here. Have you understood it? Do you have any questions? No. Okay. The rest is your home task, students.